Hey everyone, welcome to another episode in Physics is Fun. Today is going to be about tension in multiple ropes and pulleys. Let's jump into reading the question. A mass, big M, is held in place by a force F on a massless and frictionless pulley system. A. Draw the free body diagrams of the system. Find B. The tension in each section of the rope, T sub 1, T sub 2, T sub 3, T sub 4, and T sub 5. And C. The magnitude of F. Let's draw the picture for the problem. Some rope is hanging from the ceiling and holding up a pulley. Another rope comes around the pulley and loops around onto another pulley, attaching back to itself like this. Then a mass is hanging from the rope connected to the other pulley. A force is tugging on the rope down, and so in our rope we should mark the tension T sub 1 here, T sub 2 here, T sub 3 here, T sub 4 here, and T sub 5 here, with the mass hanging. With the picture drawn, we can move on to part A and the free body diagrams. Starting with the mass and a base, the mass has a weight, so m times g, down or in the negative y direction, and also the tension holding it up, so T sub 5 in the positive y direction. We can also draw both pulleys as they are not fixed and can be helpful to use. Pulley 1 is the smaller one, so starting with a base, this pulley has a tension holding it up T sub 2 and another tension T sub 3, both in the positive y direction. Then the tension down is T sub 5. For pulley 2, the bigger one, it is being held up by the tension T sub 4 and also has three tensions down of T sub 1, T sub 2, and T sub 3. With the diagrams, let's write out all the force equations for each diagram. Starting with the mass, T sub 5 minus m times g will equal 0. As we noted, the system is not moving, therefore our acceleration is actually 0, giving the right side equaling just 0. Now for pulley 1, T sub 3 plus T sub 2 minus T sub 5 equals 0. And for pulley 2, T sub 4 minus T sub 1 minus T sub 2 minus T sub 3 equals 0. We can rewrite the mass one to be T sub 5 equals m times g by adding that mass over. We have the equations written, but so many variables. We have to take a closer look at the picture and realize that there are three ropes, one from the ceiling, one around the big and small pulley, and one hanging attached to the small pulley. Remember, the tension is the same across one rope, so really the one string with T sub 1, T sub 2, and T sub 3 are all the same tension in the rope. So instead, I will rewrite all these same tensions as just T sub 1. Going back to our equations, we can rearrange and get simpler equations. For the pulley one, the T sub 3 plus T sub 2 will really add together and equal the T sub of 1 since I made that change. So 2 T sub 1 minus T sub 5 equals 0. For pulley 2, we have the minus T sub 1 minus T sub 2 minus T sub 3, so really just minus 3 times T sub 1. So T sub 4 minus 3 times T sub 1 equals 0. The equations are looking much better, so our free body diagrams are done. Let's move on to part B. To solve for all the tensions, we need to manipulate all the equations to solve for each one, but also we are really only solving 3 for the different tensions in each rope. The equations are T sub 5 equals m times g, 2 times T sub 1 minus T sub 5 equals 0, and finally T sub 4 minus 3 times T sub 1 equals 0. We need to start simplifying, so it is time to calculate. Taking the second equation, we can solve for T sub 5, so 2 times T sub 1 minus T sub 5 equals 0, and add t sub 5 to both sides and cross out on the left side. Now 2 times t sub 1 equals t sub 5. Now divide both sides by 2 to get just t sub 1 alone, and get t sub 1 equals t sub 5 divided by 2. Well, we have t sub 5 figured out to be m times g, so substituting in, we get t sub 1 to equal m times g all divided by 2. Let's write this down over here for t sub 1 through 5. And t sub 1 through 3 will equal the same m times g over 2. We have t sub 5 equals m times g. Now to solve for the last t sub 4, we need to plug in for the last equation, rewriting t sub 4 minus 3 times t sub 1 equals 0. Add t sub 1 to both sides and cancel on the left side to get t sub 4 equals 3 times t sub 1. We know t sub 1, so let's plug in now and get t sub 4 equals 3 times m times g divided by 2. So t sub 4 equals 3 halves times m times g. Let's write that in for t sub 4 now. And with part B solved, let's finish off with part C, find the magnitude of F. Remember, force is equal to m times A. And if it's acting on the rope, the tension in the rope is the same as the force pulling on it. So in this case, F equals t sub 1. Therefore, the force is just m times g over 2. After drawing our free body diagrams, we wrote and manipulated the equations to find and solve the force and the tensions, t sub 1 through t sub 3 equaling m times g over 2, t sub 4 equaling 3 halves times m times g, and finally t sub 5 equals just m times g. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and see you next time.